In this video, we're going to determine the concavity from a graph. Let's use the graphs below to determine whether the function f in blue is concave up or concave down. Now visually, by looking at these, you could probably guess concave up, concave down. But let's be a little more precise. Say this is point A here, and this is point B. Let's consider the slope of the tangent line here and here. We can sketch in some tangent lines. There's one of them. And there's the other one. They both have a positive slope. Now, which one is steeper? This is a positive slope. And this slope here is more positive, since this line is steeper. So we can make a little mini graph of f prime here. So at A, we definitely have a positive slope. We're about here. And at B, we have a more positive slope. F prime between A and B would look like this. So the first derivative of f is increasing, so this is concave up. All right, now let's look at this graph here. And again, let's pick out some points. Say A and B. There we are. There are points A and B. Now we can sketch in our tangent lines. And let's see. Well, this tangent line is positive, and this tangent line is also positive. Now, if these are ladders and you're walking up ladders, you're this little person here walking up these ladders, or not ladders, excuse me, stairs, which one is going to be easier to climb? Well, this one will be easier to climb because it's less steep. Now that we've seen that, we can sketch a little picture of f prime again. Okay, so let's sketch our picture of f prime. At A, at x equals A, we have a positive slope. And then at B, our slope is still positive, but notice the slope at A is more positive. The slope of this line is larger than the slope of this line. So at B, we can draw our point here. So between A and B, f prime looks like that. This is decreasing since now we're walking downhill on these steps. So since f prime is decreasing, f is concave up. Okay, let's try this again with the bottom two graphs. So again, I selected points A and B here. And let's go ahead and sketch our tangent line. So this one here is negative, and this slope here is negative. Both slopes are negative, so which one is more negative? Okay, so here we have this negative slope, and this one is steeper, more negative slope. So now let's sketch f prime again. Since the tangent line is negative at A, that means we'll be below the x-axis. And since the tangent line is negative at B, we'll also be below the x-axis. So now it's left to determine which one of these slopes will be closer to 0. This one's really steep, and this one's flattening out. So this slope is further from 0, and this slope is closer to 0. So f prime looks something like this. So f prime is increasing. That tells me that f is concave up. Finally, let's look at this last one. Here's A, here's B. And let's draw a tangent line here, and then draw another tangent line here. All right, so let's use that information to make our sketch of f prime. This is a nicer, calmer slope, so that means this slope is closer to 0, because this is ground level. See, if you're walking here, you're flat, you're good. And then you start going downhill here, and this is when you're going really far and fast downhill. So at A, we're a little closer to 0, and at B, we're further away from 0. And between A and B, f prime would look like that. So f prime is decreasing. Notice these are downhill steps. So f is concave down.